for 2, and it's all going to be about relative atomic mass. Now, there is a definition you'll find almost in every GCSE textbooks where it goes something like this. This is the mass of an atom of a particular isotope compared to 1/12 the mass of a carbon atom. Okay, bit of a mouthful. Doesn't really give you any more information than that if you're actually trying to go for a bit of understanding. Now, if you're not really worried about understanding, you can just memorize it and you can stop watching the video here, I suppose. But if you actually want to know what that means, therefore you have to remember a lot less stuff, all you have to do is try and decode what this means. So, this is the mass of an actual atom. And it has to be a particular isotope. Let's go through this by example. Let's say the particular isotope that we're trying to deal with is, I don't know, lithium-7. Lithium-7. We need to know the mass of lithium-7. Let's say the actual mass of lithium-7. Got it next to me. It is very small, as you can imagine. It is 1.16 times 10 to the minus 23 grams. That's how much one atom of lithium weighs. Don't worry actually how they work out the masses. That is the actual mass of a lithium atom. Lithium-7 to be exact. And to work out the relative atomic mass, you need to compare that to 1/12 the mass of a carbon atom. Okay, well, how much does one carbon atom weigh? We've done this a little bit in video 1. A carbon atom weighs 1.99 times 10 to the minus 24. Sorry. Minus 23 grams. Incredibly light, actually heavier than lithium atom. But we're not comparing it to the actual mass of one carbon atom, we're comparing it to 1/12 the mass of a carbon atom. So step 3, multiply 1.99 times 10 to the minus 23 by 1/12. And you will find, if you do that on your calculators, you will get a mass. You get a 1/12 of the mass actually, which is 1.66 times 10 to the minus 24 grams. And this is where we need a little bit of explanation of what the word relative means. Now, relative is just something that we compare against. So for example, let's say I weigh 160 kilos. I do not. But let's say I weigh 160 kilos. Let's say we don't want to express my weight in its absolute value, the absolute value being 160 followed by kilograms. Let's say we want to express that in a relative way, just in comparison to something else. Let's say the person we were comparing it to, let's call him Bob for a week here. Let's say Bob weighs 80 kilograms. So to work out the relative mass of me in comparison to Bob, what we do is we take 160 kilograms and divide it by Bob's weight, which is 80 kilograms. Now that means I am 2 times as heavy as Bob. Okay, so let's say this time we have a person who weighs 240 kilos. And we want to work out the relative mass of this unknown person. We always have to compare against Bob because that's what we've chosen arbitrarily. That means we could have chosen anyone, but we've just decided to choose Bob. Okay, so what we do is we put 240, the top divided by 80, and rather than me being twice as heavy this time, this random person is 3 times as heavy as Bob. So you get the idea. Rather than saying the actual number 240 kilos, we just say 3 times as heavy as the thing that we're comparing against. Just so happens to be Bob in this case, but we could have chosen anything. So that's all relative means. We compare against something. Now, going away from numbers that we actually can imagine, to move to the chemical world where things are really, really, really tiny and don't weigh very much at all. So, we know what our standard is, or the thing that we compare against is, and how much that weighs. It weighs 1.66 times 10 to the minus 24 grams. Just like we did when we were working out the relative masses of people's weight. And let's put that number at the bottom. What we need to do is compare that to the actual mass of a lithium atom. We know, because I've said from my source on the left of me, that a lithium atom weighs 1.16 times 10 to the minus 23 grams. Now if you calculate that on your calculator, you will find out, or you will work out the number that you see in the periodic table. Now it does not have units because the grams actually cancel out, but the number you will find will be 7. And this is the relative mass. The relative masses don't have units of a lithium atom. Now, if you had a mole of them, if you had a mole of those atoms, they would weigh 7 grams for every mole that you have. So that is also equivalent to the molar mass, but remember that the molar mass has units of grams per mole, as a relative mass does not have units because when you work them out, the grams actually cancel. So instead of comparing lithium this time, let's move on to carbon. So we know that one atom of carbon actually weighs 1.99 times 10 to the minus 23 grams this time. So if you calculate that on your calculator, what you'll actually get is 12 or 11.9 maybe. But that is the relative mass of carbon. Now, if you wanted to know the molar mass, well, you know if you have a mole of them, it would be equivalent to 12 grams per mole. And that's where the relative atomic mass actually comes from. Not too difficult, you just need to be up on your standard form.